it's a fun little challenge. Look it up, Advent of Code, someday when you have a little bit of time on your hands. This is interactive, meaning I'm going to say things. I did not intentionally put Easter eggs in this one. I'm not above doing that. But if you find me saying something wrong, call me out on it. If you know resources for this stuff, let me know. These slides have not been shared yet, and so we can modify them, and I intend for that to be done in here if we can. And as I see some people doing, the first order of business is to sign in. If you sign in and you have a CLD, you can register to get points for recertification. CLD, CLA, that kind of thing. I don't know if the teaching one does. Anyway. Okay. Oh, sorry. I didn't print out any. I should have printed it on paper. Let me know. I'm sorry?
There's 2 QR.
Oh, thanks, Will. I assume those are from you?
Yeah.
Thank you. Yeah, so I'm going to move on, and later you can log in if you haven't done that. Does anybody need me to wait any longer? That gets you where you need to go?
Yes, sir.
All righty. Okay, we're going to be talking about data communication, and we're going to be talking about sort of a narrow portion, but I want to kind of give the scope, a broader scope to begin with. And so I'm calling them channels, even though there is such a thing called a channel wire, and that's a very specific form of communication or technology. That's not what I'm referring to by channels. And so this is just kind of a list of where we're going, just to see, so y'all can see where we're going to be going. First thing is, I've got 2 computers. Do they look like computers? Well, maybe back in the 80s. Each one of them has processes running on it, and you will see, oh, I meant, now you can see my mouse. Okay, so we have, I've listed 4 different communication channels. One is a process communicating with itself. This would be typically used for communicating between threads in a single application. The next one, which we're really not going to talk about, is between a process and a device. A device means like a PLC or a sensor, something that doesn't have much computing power. There's inter-process communication, which is between 2 processes on the same computer. And then finally, there's network communication, which is between processes that live on different computers.
Let me ask if the music is too loud for y'all. I'm keeping the doors open so that when food comes, you can find us, but I close the doors if you need to.
And if you'll take this phone when she calls, you can answer it. Okay, so that kind of describes the channels. And all right, so the interprocess is things in LabVIEW like global variables, channel wires, queues, notifiers, functional globals. Does anybody need us to pause on that one? I know that there are more. You can use wires to communicate, but I'm just hitting that one at a very top level to let you know the kinds of things that we're talking about for intra-process. With communication with devices, you can just see that word too many to list. There's just a ton of different ways. Modbus, CAN, GPIB, Ethernet IP, Profibus, BACnet, and the list goes on. Also things like MQTT and something called CoAP that I've never used, but there are others. And then in inter-process communication and network communication, that's what we're really going to focus on today, so I didn't really list them in here. All right, so the inter-process and network communication, they're typically based on Ethernet and Internet protocols. We don't typically use serial buses for this, or smoke signals, or anything, or Morse code even. And there's significant overlap between these two, between inter-process and network communication. It used to be that the division between those was a lot bigger than it is today. Today, you typically, anything that can work inter-process also works in a network setting. So we're not going to really care about that distinction. When you are working with inter-process or network communication, the things that you might want to be concerned about, and here would be a really good point, a place for you to let me know ones that I left off the list. Ease of implementation. Some of these are pretty easy to work with. Some of them are pretty complex and require a good bit of setup, a good bit of knowledge. Data throughput. Data throughput is basically speed. How much data can I get from here to there over what time? Security, especially in the networking world, you care about who can do what to whom. And data integrity has to do with, did what I sent get there? Sometimes we care about that kind of thing. Scalability is, if I'm making changes to the process, what can I do and how easy is it to make changes to incorporate or to broadcast, if you will, more and more data? Which technology allows me to do that in an easy way, and which kind of are you bottlenecked from being able to grow? And another thing that is sometimes of consideration is, can I integrate my LabVIEW work, project, application with other programming environments? Where this a lot of times is needed is when you're working as part of a team where other pieces of the system were done in a different programming language, and they're not going to go out and rewrite it in LabVIEW for you. So you want something that can work sometimes in an environment where you have different programming languages involved. Ha! Look at there, sir.
Would you consider packageability is something we sneaked up on? That might
Okay,
list.
Good.
There's a bunch of different ways you can do things, and even if you build all your applications from scratch, after a while, you wear some ruts. You get used to using certain tools, which means that you need certain support code to go with it, and maybe the ability to wrap all that up in a
Like an Docker image or something.
A package or something like that, where you got all your support or everything associated with it.
Okay.
So that it's easily deployed maybe to a variety of applications.
Do you want that to be a separate bullet, or would it be possibly part of implementation? Do you want to call it implementation / deployment?
Sure.
Reuse.
Yeah.
/ deployment. Because deployment can really come back to bite you big time if you're not careful. So yeah, I like that. Is that acceptable? The theory is that since this is being archived, that other people can come back, and so I want this to be a tool that's useful in the future, this set of slides. Okay, now, because we're talking about Ethernet and Internet, we get into some really boring stuff, and I'm only going to show this chart by way of reference. There's a thing called OSI. I don't even remember what it stands for. Somebody can look it up and tell me. But there are 7 layers, and basically, and most people present these with layer 7 on top. I just did it top to bottom to be different. Physical is the bottom layer, so to speak. It is the hardware layer, and it's ones and zeros. I do have a link here. I believe it's the Geeks for Geeks website that has a set of pictures that show these layers spelled out in a pretty neat way. And I don't know, I'm not an OSI guy. I'm only letting you know that these basically, when we talk about channels of communication, it's going to be hitting at a level from 1 to 7. The closer you are to level 7, a lot of times restricts your throughput because you've got more and more pieces involved. So if you're looking for something that's really fast, you want to stick up there in layer 3 or 4. And so that's the reason that I'm showing this is that the higher the level, typically the lower the performance. However, what comes with that is ease of implementation. The higher the level, the better the odds are you're going to get the project completed on time. So basically, if you can abstract this away from the rest of your code, you'll have the opportunity to refactor and drop it down to a lower level if you need a higher throughput. That's just kind of a word of caution there. Do we need to go through this any further than I have? I don't know what these levels mean a lot. I just know that they're there, and they're basically things that you can use as triggers to go and look for more. You can research these. Okay, and I do have some slides here that show now the different technologies, and here's where I'm hoping for some help. I tried to scour the internet to find out what we can use. Some of these obviously are not LabVIEW only, and some of them you would work with the system exec and you wouldn't even implement it in LabVIEW likely. So there may be several that you think are important to be part of these slides that I have not included. So that's one of the things I'm looking for on the interactive, is for somebody to label them. So I'm just going to go through the ones we've got, and then I'm going to pause for input on ones that I have not mentioned. So everybody knows what network published shared variables are. Yes, raise your hands if you do know. I'm seeing hands that are not going up. Well, honestly, everybody knows, I don't want to spend time with it, but if somebody doesn't, it uses an engine, and it is usually LabVIEW only, but you can implement network published shared variable client, I guess you could call it, in .NET. It does not have any security other than what you bring in. And basically, I don't know, to me, I think of network published shared variables as being end-to-end, meaning I can have producers of data and consumers of data, and they can be one and the same. You can be a consumer and a producer, and it just doesn't matter from the standpoint of network published shared variables. They are considered thread safe, obviously, and so you basically can dictate who gets to read and who gets to write, and that kind of thing, to keep things, to maintain data integrity. But that's kind of on the user, the developer, I should say, to implement safeguards on who can do what to whom. There's a thing called simple TCP messaging, and I will let you know which ones of these I've used and which ones I haven't. I have used network published shared variables to share data between a CREO and LabVIEW running on a desktop computer. I have not even heard of simple TCP messaging. It is a LabVIEW tool. My understanding is it can be implemented in other languages. All of the data are strings, so you have to do the what I call the dehydration and rehydration. You have to turn your data into strings, and then on the other end, turn it back into your data. No security, high performance, and it is scalable, and it's typically point to point. Did I say anything wrong?
Sorry, I have a question. What is OSI layer?
Oh, I'm sorry. Okay. So good. Yeah, thank you. Thank you. So layer 7, that's right here. Layer 7 is the application layer. It's the highest layer. And that means it brings along with it all the lower layers as well.
You had said somewhere, look it up, open systems interconnection.
Open systems interconnection. Thank you. OSI. So that's the layer at which it was implemented. And that can be a guide to judging throughput, for instance. It also, basically, the higher the level is a higher level of abstraction, which means that you actually usually can do more with it, so to speak.
Are those numbers like a standard?
Yes. Yeah, anytime you see OSI layers, that is the list of the layers, and that's usually what they're named. Just to be able to give you this text in the 72 font that it is, I think it's like 18. I whittled it down a little bit. So it used to call it physical layer, data link layer, network layer, and all that. But I tried to make the text bigger. So I threw away parts. So that's what OSI layer is. Network streams is a LabVIEW technology. It's implemented at layer 3, which is the network layer. Very high performance, no security, and it's peer-to-peer. Both TCP and UDP, there are significant differences in them, although you'll hear those words used in the same conversation a lot of times. But Transport Control Protocol, I think is what that stands for, is implemented at the transport layer. Obviously, it is not LabVIEW only. It is a primitive, meaning that you get to implement all of the bells and whistles that you want to bring into it on your own. And that means structuring your data, however you interpret data, package it, that kind of thing. And the reason I say connection-based, that's important for two reasons. One is UDP is connectionless. So when you're deciding between these two, basically TCP is peer or point to point. It's one client, if you will, to another client. You could think of it as sort of a client-server relationship, or just two things talking to each other. If you have it going both directions, you'd have two channels, if you will, two connections. And it is or can be secure, and that is, now I'm drawing a blank on what TLS stands for. Transport, I don't remember. But you can build secure TCP connections, relatively straightforward. But you build up what you need for each situation. There are a lot of people who roll their own libraries that they reuse for this purpose. UDP is usually used for casting. It's very high performance. It certainly is not LabVIEW only, but it's used for throwing data over the fence to another application. It is unsecure. You can add security to it, but it is basically one device spitting out data to somebody else. And when I say you can make it secure, you would have to bring that in yourself. I don't think it's usually done. You're usually, I've never used that one, by the way. I've never used TCP directly. I've never used UDP directly. WebSockets is a tool that is used in LabVIEW, but it is not LabVIEW only. It is at the OSI layer of application layer. It is a tool that's used for making connections where you want to maintain a connection for a long period of time. Usually the one where I would contrast it with the TCP up here is that TCP, you usually will make a connection, do stuff, and if you need to maintain a connection, you can't count on it staying around unless you do some sort of a keep alive. So usually if you need to do maintain a connection, you use something like WebSockets. And to secure it, you use something called WSS. If you're just using the unsecured, you can use something called WS. And it, again, is peer-to-peer. Questions?
Bergman's?
Louder.
Bergman's?
Okay, yeah, what she's referring to is there's a company locally called Bergman's Mechatronics, has a tool called LabSockets, and it is built using WebSockets. It is a way to bring a LabVIEW front end to a remote device, either intranet or Ethernet or internet. Yeah, it's in there. It's in the. So we have indirectly used WebSockets through LabSockets, but we've not used WebSockets. But yeah, you're right. Absolutely. Okay. I'm betting all of y'all have heard of HTTP web services. You think of RESTful API as a kind of a buzzword for that. It's built on the application layer. Obviously, it's multi-language. That is a good thing to dig into because you'll find uses for it in a lot of places. It is low performance, it is secure, and you can make it, the data integrity piece of it, you can handshake and make sure that you are sending and receiving what you think you are. It is peer-to-peer. We have used that, and where we have used it is from a compact RIO. We wanted to get data into a SQL Server database. The CRIO, we don't have the big pockets, the deep pockets to buy the 64-bit CRIO, so we don't have the opportunity to put a SQL Server client, or I guess that's what it's called, a SQL Server client on the CRIO. So what we did is we just threw the data over to a Python web service using HTTP web services to we actually passed files to that target machine and then processed them on the machine, on the virtual machine. And then the MQTT family, I don't know a better way to describe that. There are lots of different MQs, and MQTT seems to be the one that is most commonly used. I could have called it the MQ family, but you'll find, I'm drawing a blank at the moment, there are a lot of different ones that are, basically you can get ones that are high performance, you can get ones that are lower performance but have more bells and whistles. I don't want to go into it very far, but MQTT is a really neat tool because it's not, I'm calling it a straight out end-to-end. It has a broker. It requires a server, or a broker that is kind of like a server, and everything that interacts with it is a client, and you publish to the broker or you subscribe to topics on the broker. And what that allows you to do is to distribute information that your target devices can pick up, they can subscribe to. And what I think is really neat, although I've never done it yet and I want to, is you can actually build in something to archive all of the transactions by subscribing to all the topics, and just archive them in a database. So you can build debugging tools around this without ever affecting any of the stuff that's out there running. You will have to build in your own data structures with it, but it is a really handy tool to be aware of. It works really well even on small, like on microcontrollers and stuff. Some PLCs have an MQTT client that you can work with as well. It is secure. It has different tools that help you with security, as well as different ways your subscribers can receive data. They call those QoS levels. I really don't want to get into that. Anybody has questions about that, please see me. We've had presentations in the past, and we can have presentations in the future covering MQTT. It's a wonderful tool. Here is the list of resources that are sort of starting points for the different ones. If you sign in, we will have your address. We will send this out so you don't have to take pictures of the slides. But these are the ones I've mentioned. At this point, I want to pause. Please say, hey, why didn't you put on this slide?
There's something I've been looking into recently, which is
I've heard of that.
LabVIEW doesn't fully support it yet, but there's a pretty neat third-party library that I've been messing around with.
Okay. Is it okay if we add that at the end of the slides?
Yeah.
We go whippy down to the end, and I didn't do well. From current slide, go down. Doop. All right, so I'm going to put right here, let's stick a new slide in. Other channel, no, other communication. Wow. Methods. And that's little g,
Yeah. It's
RPC. They'll have to look that up on their own. I figured anybody in this room, has anybody ever used the Google? Okay, so we'll just use that and mark it. And anybody throw please out other ones that we need to add to the list. Okay, we're going to pick right back up here. These now deal with transferring not data, but for transferring files. And the guy who was asking for this presentation lives down in Auburn. He works for a railroad company. He's a remote worker, and he's using CREOs that are placed around the country to do testing, and he wants to get his data back to a server somewhere. And he was wanting to explore the different methods for getting his data, which happened to be a text files. I'm going to back up a couple here because I didn't say it, but obviously I've used MQTT. So the ones I haven't used are simple TCP messaging network streams. I've not directly used TCP or UDP or WebSockets. So I don't have a lot of, I can't answer a lot of questions about that. Everything on this except for SMB I've used before. It's been a while since I've used NFS. Okay. All of these are operating at OSI layer 7, the application layer. FTP is not secure. SFTP is secure file transfer protocol. Both been around a long time. Everything on this sheet is multi-language support. All of them require a server. So back before the real-time target, the National Instruments real-time devices supported SFTP. They supported something called WebDAV when they deprecated the support for FTP. So I have used WebDAV, but it's been a while. HTTP REST, there's some overlap between that and the data transfer. You can use REST to post data. And that would be a very, if you're interested in transferring files, that would be something really to take a strong look at, because a lot of the work is done for you if you use that technology. SCP is, I forget what it stands for, but it's an old Linux capability. It now is available, has been available for Windows. I'm on the wrong one. SCP is the one that's Windows only. I apologize for that. And in LabVIEW, you would use a call to the system exec to transfer. You would not do that directly from within your LabVIEW code, I don't think. And I forget what SMB stands for. I've not used it. Don't know much about it, but I ran across it when I was.
It's sort of a message block. So Windows 7 and later, like all of Windows 10 stuff is all SMB 3.0 and encrypted and whatnot. So if you're Windows to Windows, Windows to server, whatnot, it's all doing that for you. So if you're doing file transfer,
I'm doing it under the hood.
Under the hood.
Exactly.
Right? So if you can bring up a file explorer, just copy and paste, like, network drive or whatever, it's all SMB.
Thank you. That's what I'm looking for, is anybody who wants to tell me what I'm doing wrong. Yes, thank you very much, Derek. And NFS is the one that came over from Linux. And again, all of these require server, and it is secure. What I mean by a server is you have to have something on the target machine. It really doesn't have, if you use network machines, the server doesn't even have to live on the machine that is your target machine, but you have to have something somewhere that is handling the low-level stuff for you, if you will. Again, here are, and I've got different separate references for FTP and SFTP, so you'll get these slides. And now we're on to others. Please, are there other technologies that we should list? We can come back to it. And then I've got other references just kind of because they didn't fit anywhere else. And so this one doesn't really tell you what it's about, nor does, but this one is TCP and UDP. We've got WebSockets, we've got REST APIs. And again, I really suggest if you haven't looked into REST APIs, do so. And then this is the MQTT starting point, so to speak. Okay, it's supposed to be a short presentation. Do anybody want to add anything to that list? Last opportunity. And if you think of it later, we can still add it before distribution. But that's it for this. We still don't have anything. What did you find out? Okay. All right. So here we are at the end of our presentation, and I'm going to stop sharing. Yes? If I can know. StreamYard. Do I just X? Or do I stop it here? No, I'm recording it now. Okay.